The application of linear encoders on machine tools offers fundamental advantages. Linear encoders in closed-loop operation ensure that thermal errors and other influence of feed mechanisms are completely compensated. This results in exceptionally accurate dimensions and contours starting from a batch size of 1. This demo unit shows the effect of closed-loop control. It replicates a classic feed unit on a machine tool with the motor, the fixed bearing, the ball screw, and the floating bearing. The table is connected by the ball nut with the recirculating ball screw. This converts the rotary motion of the motor into a linear movement of the table. The temperature of the ball screw is measured. A length gauge is installed to ascertain the repeatability of the table position. A counter displays the position difference measured by the length gauge. A linear encoder measures the table position in a closed loop. The difference in accuracy is determined in the following way. Before the operation, the temperature of the spindle is 20.8 degrees Celsius. After 10 strokes, the influence of the ball screw's increasing temperature on the table position is displayed. In spite of a temperature increase of 2.1 degrees, the measured position value is unchanged. After 10 strokes, the length gauge does not detect any position error. This means that when the table is positioned using the linear encoder, the axis is accurate. For indirect measurement in a semi-closed loop, the table position is determined through the spindle pitch and the rotary encoder. The spindle now has a temperature of 20.6 degrees Celsius. Now, the semi-closed loop is switched on the demonstration unit and the counter is zeroed. The simulation starts and the table traverses 10 times at 60 minutes per meter. After 10 strokes, the ball screw temperature increases by 2.1 degrees. This increase in temperature causes the table position to change by 6 micrometers during these 10 strokes. These effects are also visible on an actual structural component from the aerospace industry. This animation shows the machining of this structural component, the heat it generates, and its position error during control in a semi-closed loop. The component is toleranced within plus or minus 0.02 of a micrometer. The position error during machining increases to more than 8 micrometers. This position error becomes visible with a small trick. After machining 40 parts, the first one is machined again, but with half the Z infeed. After this second operation in a semi-closed loop, an edge 70 micrometers deep becomes visible. When the part is machined again under the same conditions, but in a closed loop, the reworked part has no edge.